We have continuous function a, so to find absolute maximum and absolute minimum, we need to find critical values first. So to find critical values, we need to find first derivative of our function. We need to use product rule. So we have u times v prime is equal v times u prime plus u times v prime. In our case, u is equal 3y and v is equal y plus 5 to power 2 over 3. So now we can find first derivative. A prime of y is equal, we have to copy this expression first, so we have y plus 5 to power 2 over 3 times derivative of 3y is 3 plus, now we have to copy 3y times and derivative of this whole expression, so we have to first take down the power, so will be 2 over 3 times y plus 5 will be 2 power 2 over 3 minus 1 and times derivative of this whole expression inside parentheses. Derivative of y is 1, derivative of 5 is 0. So we have 1 plus 0 is 1. So this is equal. We can put 3 first, so it will be 3 times y plus 5 to power 2 over 3. 3 and 3 we can reduce. So we have plus 2y times y plus 5 to power 3 over 2 minus 1 is negative 1 over 3. So this is equal. We can factorize y plus 5 to power 2 over 3. So let me copy this. 2 over 3 and in parentheses we will have, in first expression we have only 3 plus 2y times, we have y plus 5 to power negative 1. Why? Because when we multiply expression with the same base, we just add exponent. 2 over 3 plus negative 1 is negative 1/3. It's the same what we have at the beginning. So this is equal. We have y plus 5 to power 2 over 3 times 3 plus, because we have negative exponent, it means we have to put down this whole expression. So in numerator we will have 2y over y plus 5. To first power you don't have to write. Because we have fraction here, I will change 3 to fraction 2. So we have y plus 5 to power 2 over 3 times. So the same denominator, we have to find the common denominator, will be y plus 5. And we have to multiply 3 times y plus 5. So it will be 3y plus 15 and plus 2y. So this is equal. We have y plus 5 to power 2 over 3 times, denominator stay the same, and in numerator we will have 3y plus 2y is 5y plus 15. So we have first derivative. Now we have to check the domain of our derivative because we have denominator. Denominator cannot be 0. So for y equals negative 5, we have first critical value because our function I prime of negative 5 is undefined, and negative 5 belongs to domain of our function, so y equals negative 5 is our first critical value. Next, we have to set our derivative equals 0, so we have a prime of y is equal 0. If and only if this whole expression, so we have y plus 5 to power 2 over 3 times 5y plus 15 over y plus 5 is equal 0. So we have multiplication here. When y plus 5 to power 2 over 3 will be equal 0, or we have 5y plus 15 over y plus 5 is equal 0. So we have to first take to power 3 over 2 both sides, so we will have y plus 5 on the left side, and 0 to power 3 over 2 is still 0. So y is equal negative 5 is first solution. And the second, because we have division here, the numerator cannot be 0, so we have to compare only numerator. 5y plus 15 equals 0. So 5y equals negative 15. Now I will divide both sides by 5. So we have y equals negative 3. So we got two values. Now we have to check if these values belong to domain of our function. Negative 5 belongs and negative 3. Negative 5 belongs and negative 3 too. So we have two critical values when we set our first derivative equals 0, and one critical value we have because our first derivative doesn't exist for negative 5, but negative 5 and negative 5 just repeats, so we have to just take one negative 5. So now we have to just calculate the values of our a function for these critical values which we got, and for endpoints. It means for negative 5, negative 1, and again negative 5 repeats, so we have to just take 1. So we have a of negative 5 to find, a of negative 3, and we have a of negative 1 to find. So we have to replace first y by negative 5 in our original equation. So it will be 3 times negative 5 times we have negative 5 plus 5 to power 2 over 3. So this is equal 0 because negative 5 plus 5 is 0. 0 times negative 15 is still 0. Now we have to put for y negative 3. So we have 3 times negative 3. In parentheses we will have negative 3 plus 5 to power 2 over 3. So this is equal negative 9 times negative 3 plus 5 is 2 to power 2 over 3. So we can rewrite this. We have negative 9 times, because we have in the numerator 3, so it means we have to take cube of 2 to second power is 4. So this is equal. We can use calculator. So we have negative 9 times cube of 4. This is equal negative 14 6.28 approximately. So now we have to do the same for negative 1. So we have 3 times negative 1. Negative 1 plus 5 to power 2 over 3. This is equal negative 3 times will be 4 to power 2 over 3. So this is equal negative 3. Again, we have cube because in denominator of this power is 3. And we have 4 to second power is 16. So this is equal, let's use calculator. We have negative 3 times cube of 16. This is equal negative 7.55. Approximately we can write. So we got values for our function. Now we have to choose the largest and the smallest values. So the largest is 0. So this is our absolute maximum. For y equals negative 5, we have absolute maximum 0. And the smallest is negative 14. So this is our absolute minimum. And this is for y equals negative 3. This is my solution.